Hello and welcome to the second in a series of webinars from Oren. I'm Dan Brightmore, editor of Mining Global magazine. We're excited to be working with Oren's founders, Shell and IBM, and focusing on how the mining industry can accelerate its transformation to resource the future. Today's theme is scaling AI in asset-intensive industries. In pursuit of that goal, Shell and IBM have combined strengths to create the first B2B marketplace for mining and industrial sectors. The Oren Marketplace offers solutions, software, services, and integrated workflows to accelerate digital and sustainability transformation across the end-to-end value chain. Shell is a leader in energy and lubricant services, boasting strong B2B mining and industrial ecosystem relationships and over 100 years' experience in industrial operations with a global integrated value chain. IBM is a leader in cloud, AI, data, and analytics solutions. Offering proven mining and industrial services, the company has been on a quest for new technologies and global innovation throughout its 100-plus year history. In today's webinar, we will take a look at how artificial intelligence has shaped asset-intensive industries and addressed issues around safety, equipment optimization, and workforce management. You'll take away valuable insights to help step change how mining can approach AI. During the webinar, if you have any questions, please let us know in the chat. We'll hear from three sellers on the Oren Marketplace, Uptake, Minerva Intelligence, and Motion Metrics, and learn how they can support mining's quest to extract resources efficiently, sustainably, and cost-effectively. Now I'm delighted to welcome Dan Jevons, General Manager for Data Science at Shell, and Ben Amava, Global CTO at IBM, to tell us more.
Well, thank you very much, Dan. Appreciate the time. I think this is a great opportunity for Shell and IBM to make a significant difference, particularly in the capital-intense markets, specifically mining. My PhD is an industrial and systems engineer, also a licensed professional, and been studying most of the complex industries as far as artificial intelligence, IoT, robotic process automation, and data analytics. I think this is a journey that all industries are particularly being exposed to, but the benefits to the mining and chemical industries are making a significant difference in the world today.
Hi, and it's a great privilege to be here. I'm Dan Jevons. I'm the General Manager for Data Science at Shell, and I've spent most of my time over the last 6 years trying to figure out how you develop, and embed AI technology across a large industrial enterprise. That's been a challenging journey. It's been one I've deeply enjoyed, and hopefully I can share some of those learnings with you over the next little while. Before that, I started off life as an Accenture consultant, so sorry to Ben for that. And then spent a bit of time in the consulting industry, and then joined Shell, and have been through a variety of big systems integration, IT strategy, architecture, and now, of course, data and AI. I guess the common thread, though, which is probably the most sort of relevant part of this, is that throughout my career, I've been focused on trying to transform business using a combination of data, analytics, and process. And I think that's where this all comes together. How can you take new data, new sources of data, leverage sophisticated algorithms, and then apply them to business processes in a way that you can change the way in which things are done? And I think that's the true opportunity that we're discussing here today.
Well, thank you, Dan. And so we've got an opportunity to explore many themes today. Perhaps I could start by asking you both, how has artificial intelligence evolved since its inception, invention, and where do we see it progressing in the future?
Artificial intelligence is really a derivative of some of the operations research, software engineering, and human-computer interaction. It started in 1958 for IBM with Carnegie Mellon and MIT. Back then, it was actually a basic research. How can we codify tacit knowledge and apply it to do three things: cost efficiency, developing new products and services, and better understand the market, maybe something through customer aggregation. Because of this, it has become an overlap or combination of our traditional data analytics. It is a process that is improving quite a bit, because what we saw in the development and maturity of application of artificial intelligence, it always had to deal with 85 to 95% of the time with the process. How do you enable technology to actually be applied to the benefits and outcomes of the business challenge? In that, if you understand the process, which it has been accumulation of not only industrial or mining best practices, it also integrates software, systems engineering, and data analytics. What we've also discovered since 1958 in its application and success, underneath that process, there's been three major elements that actually have provided not only the commercialization of machine learning and artificial intelligence, but the benefits that everybody is so intrigued to get. That revolves around three elements. That revolves around data, talent, and trust.
What we've seen, maybe talking from the implementation side, is that it's really only recently that the scalable enterprise-grade platforms to deploy AI across an enterprise like Shell have been truly available. We perhaps not as much as IBM, but we've been experimenting with this for some time. Of course, we've had a long history of looking at computational science and machine learning, and we've been doing that in our research labs for many years, arguably right back into the 1970s. But I think it's really recently, as Ben's described, where it's been sufficiently available and accessible to IT teams, to data engineers, and some of these new breeds to allow us to deploy the algorithms which are developed by data scientists at scale, and then importantly to manage them at scale, because it's all very well developing an intelligent system, but maintaining one is a different ballgame.
I think where it's really come to play, and where Shell and IBM have done an excellent job, is when I look at what makes it successful today, it always goes back to data, talent, and trust. And what Shell in particular has done very well with their educational system and individuals like Dan leading new organizations, they're actually building up the talent through this knowledge transfer. So they don't do it in one area or department, they're making it pervasive. Because what we've also seen in the last 5 to 10 years, where artificial intelligence and machine learning has been democratized, it's its capability to actually have good user interface and the knowledge to use that. And that, I think that's one of the critical paths. What we've also seen out of the four audiences that have benefited from machine learning and artificial intelligence is the following four in order of importance: implementation and business justification. Experts within the business, why talent is very important, followed by analysts, whether you call them data scientists, data engineers, or business analysts, they've matured. Followed by senior executives, right? You need that sponsorship, and they see that from experts within the business, the analysts, and then finally IT. What you don't want to do, and what caused the two winters that Dan was referring to, is when what I call the boat, the business, the organization, the algorithm and technology, it's always got to be run at the forefront of the boat, again, the business. What happened in the two other previous winters as technology was in the lead, and we were essentially driving the boat or this vessel backwards, which ran into issues. Or we were so heavy on the technology side, it had a tendency to tip over. So now the boat's balanced, it knows where it's going, and it also knows where it's been.
And I just want to build on that, because I think, Ben, you put it very well. I mean, I think if I talk about how we've tried to go about that, we've developed this thing which we call the Shell.ai program, which I think just exemplifies some of the things that you're talking about. You know, really broad, democratized learning for large swathes of our IT department, which IBM's worked with us on, as well as also highly specialized training for a niche group of data scientists and AI engineers who we're trying to upskill to be the cutting edge talent that we need to understand this space. And we've worked with companies like Udacity to create that. But as part of that, we've created this integrated whole where we're training specialists who are focused on the technology. We're training the business in a democratized understanding. And then what we're also trying to do is build consistent platforms and ways of working to allow that to be deployed at scale, as well as a common narrative about where the value is going to be within the business, which is critical, and trying to get that aligned with where our executives want to go through roadmaps. And I think it's that enterprise-wide change program that you're describing, Ben, which is so important in all of this, because I think if you look at this just as a technology play, or if you look at this just as a sort of a business play, you miss the point. Actually, it's a holistic change program to really make this work. And I think that the way you've described that is really important to get your head around.
And Ben, where do you see that progressing? Dan's kind of talked about how they're pushing towards the future.
I think that it is actually progressing in value quite a bit for, again, the business, the organization, the algorithms, and the technology. Today, for a miner, right, for taking down one of the heavy machines, within 24 hours, it could cost them between $1 million to $1.5 million, right? This is the business challenge you're running into. And not only the machine itself, the value of the inventory in 20 minutes could cost you up to $60,000. So by identifying this value proposition and migrating it not only from the business to the organization, the actual algorithm and the technology that supports that is very important in this evolution and the application of artificial intelligence. What has actually happened to actually expedite this technology? Moore's law finally caught up, right? The ability to actually process things faster, not only on the computer or the microprocessor side, but also through the network. In that, there's another law called Metcalfe's law. Metcalfe's law says that the value of the connections of individuals, again, everybody in that organization and algorithm actually has come together. For example, the cell phone by itself has very little value if only one person in the room has that cell phone. The compression of Moore's law coupled with Metcalfe's law is making artificial intelligence and machine learning even more valuable, because it's on its onset, it was never replace individuals. It was meant to complement individuals as a cognitive capability. And through trust of these algorithms are going to drive it forward, like other technologies that we've seen, from robotic process automation, IoT, and blockchain. It is the analytical part that's going to take the collection part to another level.
Thank you both for that analysis of where we are, where we've been, and where we're going. But if I could come again to you, Dan, how did Shell begin its path? I know you touched on some of this, on the adoption of AI, and how has this transformation assisted in achieving its strategic objectives?
I think if you take it back to the beginning, Ben talked about leadership, and I've been very fortunate at Shell to work with some really visionary leaders. And I think it's fair to say we saw this early. I mean, my position, really, my current position dates back to 2013, when I was asked at the time to start to look into what was then being described as predictive and advanced analytics, which really was what we now call AI. And importantly, that was coming out of IT, because we saw that increasingly the research was requiring us to embed complex algorithms into software. And we needed to be able to bring the IT world, the platforms, if you will, together with the researchers to allow us to deploy them. So that was kind of the origins of it for us. But I think what became very apparent was that this was a generic technology that could be applied almost everywhere. So in the early studies, we identified use cases from treasury through to global commercial and into retail, and pretty much everything in between: exploration, production, manufacturing, you name it. And so the question was almost, where do you get started with this? But also, where do you really have the impact? And we found that actually the biggest aspect of our journey has been one of learning, firstly, to identify the problem well, and to identify problems which can be easily solved using data science and AI. And secondly, I think the other piece is to recognize that it doesn't always work, and actually to be able to fail fast. And so we developed a very rapid, agile methodology to allow us to start to test things out and see if they worked or not. I think the other big learning, and something we did very early, was we started a community, because we said, look, it's not just going to be about one team. This is going to infuse all different parts of the organization. It's going to be everything from R&D through to the engineers on the front line. So how can we bring that community together?
If I can move on, perhaps come to you, Ben. Once a series of key challenges are identified within an organization, how do you create and define the associate value proposition in reference to the integration of AI? How do you determine the ROI?
The ROI always goes back to some kind of monetary value or productivity. But to order to figure out the ROI, which is based on assumptions, I think you've got to be very specific. It's Pareto's law. And what we see specifically in the industrial sector regarding Pareto's law, you've got to focus on the 20% that make 80% of the impact. That's where you're going to get your ROI. But it's also got to be at minimum on 3 dimensions to actually see it, whether it's productivity, whether it's quality or time. Those are the 3 levels. Again, productivity, quality, or time. If you can remove the variance of that, or at least align capacity to demand, then you'll start actually calculating the ROI that business leaders and experts need to do to actually identify the challenge. Just because it's a challenge doesn't mean that machine learning or artificial intelligence should be applied. In some instances, it could be simply signage or just a manual change in the process. But in order to do that, we've got to be very smart. And to find the ROI, and why I call it SMART, it's an acronym. You've got to be very specific. It's got to be measurable, again, with the 3 dimensions, time, quality, or resource. You've got to be able to audit it, right? An ROI that's unauditable really isn't a true sustainable ROI. You've got to be able to reuse it, and you've got to trace it back to the original requirements, i.e. the ANOVA, analysis of variance, to actually produce that return of investment. 52% of C-level executives expect that machine learning and artificial intelligence applications, the A in both, will actually come from other industries. And that's why I think companies like Shell can take their best practices into the mining industry with the range of ROI that the mining industry should expect to see.
And are there 7 steps, I think, that were in your presentation that you'd perhaps like to expand upon a bit more as well?
Very, very important 7 steps. It's called the minimum standard of care. The first thing, in order to capture the return of investment, it could be productivity, it could be time, or it could be resource. That is broken right now in best practices. It's a combination of manufacturing, systems, software, and what they call data analytics capabilities. Those 7 domains are the first domain, domain 1, is actually being able to frame the business problem. Again, you can't try to solve every problem because it might not have the feasibility or the priority. The second domain is the analytics problem. Can we frame that mathematically? Because the data may not be there, again, to be smart, all the way to traceable and reusable. Then you're dealing with the data. 40 to 80% of the time, people are actually, instead of actually analyzing, they're trying to cleanse the data, prepare the data, fill fields that are either incorrect or blank. Then it moves to the methodology and approach. Should it be a simple linear regression, scattering, or true machine learning? Then you build a model. The 6 is you deploy the model. And the most important thing that we didn't realize in past is how do you actually govern the entire life cycle? Because what we do know from best practices, it always is in a closed iterative circle. So like Dan referred to, we want to fail fast, but we want to learn from those experiences and not reinvent the wheel. So those 7 domains, I think, are the minimum standard of care today. And I think that is probably the basis of advancing or democratizing machine learning and artificial intelligence.
Thank you. And I'd like to ask you both, and perhaps I'll start with you, Dan, about some of the challenges that your customers are facing and how the adoption of AI is helping them alleviate some of those pain points.
Maybe I'll start with some internal cases, because I think that's, I always think it's good to talk about your own challenges and some of the things that we're working through. I think, we've seen very, very broad applicability of the technology. And maybe I'll just describe one particular case, which is around predictive maintenance, where we spend a lot of time and effort. And in predictive maintenance, what we're trying to do is effectively develop algorithms that try to identify where things are going to fail in the near term. To do this, we've actually had to aggregate about 1 trillion rows of data to date. That data volume is growing by about 10 billion records a week at the moment. And so we're bringing all of that into a centralized data environment. And so we focus quite a lot on things like valves and compressors. And the reason we've done that is, for us, these are high value pieces of equipment. And if they fail, then they have a significant impact. So I wanted to use that as an example because I think it exemplifies the closed loop system that Ben's describing. It's something we've done to ourselves internally. And I think the challenge of digital and AI is figuring out how we can work together on problems. And I think that's also where Oren is so strong. It's trying to create a collaborative group of companies coming together through a marketplace for fair value exchange. And I really love that concept because I think it's what this is all about. We shouldn't be arrogant enough to think we've got it all figured out, but we also need to recognize that all of us have parts of the solution, and together we can make something much stronger.
Thanks, Dan. And Ben, are there use cases that you'd like to highlight here?
Yeah, I think, there are three primary use cases we see around the world in order of importance. And number 1 and 2 actually go back and forth. It's the actual production, the actual mining, the extraction, the separation, and the smelting. The second one is the supply chain. Now, because of certain externalities, that was simply based on cost in the past. The third use case that has been surfacing worldwide is also based on external factors, workforce optimization. So there's always 4 elements. You're trying to get better collection, better analytics, and better response. That's machinery, materials, money, and people. Those are the use cases that are surfacing and continue to be a priority moving forward to the future.
And moving on to our final kind of areas of discussion, and based on both of your experiences, what are some of the key lessons learned in AI adaptation? And I know AI adaptation, I know we touched upon some of this already, and integration into larger companies. What can Shell and IBM do to help organizations begin or expedite their transformation?
I think the big learnings for me are really around the importance of trying to bring together multidisciplinary teams early in the process. I think when we started this, we very much focused on trying to use data scientists to solve problems. It's much more about trying to bring together groups of people from different disciplines and backgrounds to build a product. I guess the other thing, and it's something that I talk to my team a lot about, is being open to build something really bad initially, but build the cheapest thing we possibly can to prove whether or not the value's there before we actually build the full scale software solution. I think the third learning is a real sense of humility and looking beyond the borders of your own organization. We have recognized that we have a part of the answer, but actually the most successful cases we've had have been ones where we've partnered. And so having a really open mind is really crucial as you think about where value is going to come from using AI.
If I come to you, Ben, and ask you about the importance of integration in large companies, and in fact the importance of collaboration, as Dan has discussed as well, and some of the learnings you found.
Let me go and add to build on what Dan is saying, and why I think Shell and IBM's partnership with the rest of the community was so impactful, because both Shell and IBM have a long history. Both organizations have been able to provide a 3-step approach based on lessons learned. We always offer health checks. Then we try to do, hey, ask an expert. Put 2 bodies or 2 institutions that are well known. They become experts and they become a source for the body of knowledge. And the final thing is, what do we offer? And again, this WebEx is a perfect example, is how do we upskill or rescale traditional workforces in the past to actually get them to this level to take us in the future. The other thing that I find very intriguing, especially at Shell, is many of these engineers have professional engineering licenses. And what does that say regarding trust? That means these individuals that have been around for quite some time dealing with analog systems to protect not only the health, safety, security of individuals, platform, and environment, they hold the capability to be accountable, liable, and suggest the best steps forward. So when I look at lessons learned, I think by doing this, we're able to satisfy the physical, mathematical, and social sciences. We're dealing in order of importance too, and actually solutioning the data, the talent, and the trust. That is going to expedite the capability of democratizing not only machine learning and artificial intelligence, but it's going to be the baseline on how we integrate data to our traditional operations research, i.e. the 1850s and 1958, to make this an evolution or improvement of what we do today.
And Dan, if I could bring you in there, from your experience at Shell, and I know you spoke about the company's own transformation and work with predictive maintenance, what are some of the other transferable applications that you can see for the mining sector? And perhaps some use cases I think that you might want to discuss that you mentioned, that I know are in your presentation as well.
So I've spent about the past 6 years looking at applications in the energy sector for AI. And I think what amazed me is as I started to have a conversation with some of our folks who are working with mining customers is just how much transferability there really is. The first that struck me was around spare part inventory. We struggle with managing spare parts for all of our assets. These are safety critical spares that are typically have long lead times. We're dealing in remote locations. They're complex to manage. And a lot of those things transfer into the mining supply chain pretty well. And we found there's huge opportunity for AI in that space. The other one, of course, is optimization, where a lot of these complex industrial processes have multiple moving parts. We have set points in those processes that are often defined almost at design time. So we create these things with set points in them and certain limits. And actually, if you look at the process based on historical data and try and understand all of the different ramifications that actually occur in the reality of operating this process, typically we found, whether that be in our integrated gas business with LNG trains or in our manufacturing business with some of our refineries, there's lots of opportunity to tweak parameters and optimize. And I guess the final area is around using some of our internal expertise, as I mentioned, to change the way in which processes operate within the mining sector. And I'll use the example of a product we've been developing called Shell Remote Sense, where what we're doing is effectively placing an IoT sensor into an engine and then taking the telemetry off that, combining it with our knowledge of tribology, in other words, our understanding of how lubricants work and what mechanical signals can be picked up through the chemical properties of the lubricant. And we're then using that to give information about how well the engine is performing. So I think there's some great applicability, some great cross-transfer opportunities. And I think we're actually just at the start of this between the mining and energy sector around how we can start to transfer and share some of these learnings.
So I do believe the future that AI will be the minimum standard of care. It'll be part of our life, specifically in heavy capital industries. The countries that are leading in this effort on artificial intelligence based on the spend and message, specifically in capital intense industries such as manufacturing, mining, petroleum and chemical, include China, which makes about 50% of the bulk of investment, the US, United Kingdom, Germany, and France. Because of that, their suppliers, depending on where their suppliers are located, have got to be part of this ecosystem. So they're actually pulling their suppliers based on their competency through that area. And again, where do we see the future? Areas where there is a large variance and capacity gap with demand and the inability to respond is where it's going. And it's not going to take 80 years where the automotive industry took 90% of the market, or even the smartphone took 5 to 10 years. We're already seeing this in our daily lives. So for capital intense industries, if the mining industry doesn't encapsulate it or use it in especially high variance, high gaps in capacity and demand, about 70 to 75% of those businesses would either be acquired, bought out, or cease to exist, according to what we've seen today.
Now, let's take a look at some of these solutions offered on the Oren Marketplace that can help mining companies leverage the use of AI in their operations to meet the types of challenges that Dan and Ben have highlighted today. Uptake's predictive insights can inform sales leads for parts and services, increase revenue, improve asset performance, and drive customer satisfaction. To give us the lowdown on its services, here's Ash Agarwal, VP for Business Development.
Thanks for having me on this webinar. Artificial intelligence, especially the one that covers end-to-end value chain, is going to augment human intelligence. The activities, the task that humans cannot do effectively. For example, humans, we are a master of inefficient work. Exploration is inefficient. Art is inefficient. Relationships are inefficient. Exploration, productivity, and everything where massive data ingestion, data analysis is required. Humans are inefficient, where AI is augmenting. Exploration, processing, asset reliability, and end-to-end value chain, it's all going to be completely transformed by artificial intelligence when it starts to augment humans. Now, if I take a look at asset reliability, what I mean by asset reliability is that the machines today, which are getting older, there's a huge expectation from those machines to continuously deliver higher performance because my ore grade is going down. I need to run the same machine at a higher capacity for more number of hours. How AI can help doing that? Now, AI can help you as an operator understand if the machine is about to witness a problem in the future. And not only that, they can also tell what they can do today to make sure that the machine never fails. It continues to work. That's step one. Step two, while the machine is working, this is running as its 100% capacity. It should not be that the machine is running, but it's not running at its own full capacity. And finally, the third aspect of technology helping mining industry is when the machine is running, what is the quality of the product that I'm getting out of it? Is it good enough? So these three aspects, along with the whole value chain transformation, is something that AI is going to impact significantly. Like I said, mining has been looking for technologies like systems of intelligence that can sit on top of system of records and provide intelligence insights to the operators, to the users. It can augment human intelligence, human capabilities in understanding and processing that data. Now, what Uptake does is provide core industries. Mining is one of the biggest there. A system of intelligence powered by artificial intelligence sits on top of the system of records like ERP system, the sensors data and everything, and it bridges the gap between those system of records and the humans. So what Uptake does is we analyze, we process all that massive data coming from hundreds of machines, the records that the operators have kept, and we provide intelligence insights to the operators so that they can take action which will make their operation, their assets perform better. And unlike system of records, which only provide information for someone to take action on it, we provide intelligent, actionable insights. Not only we tell what is going to happen and what's wrong, we also tell what actions an operator can take to avoid something bad from happening. For example, we work with partners who give us data from the machines such as Symboticware, get data from mining machines like mobile assets, haul trucks. We collect that data and we apply artificial intelligence. And what we have demonstrated is we can deliver up to $150,000 of value from increased production, reduced cost of operation, and reduced downtime for every single haul truck. That becomes $6 million every year from a typical fleet of 40 haul trucks. It's amazing. There's so many low-hanging fruits that can be captured by application of Uptake's advanced technologies. Data-driven operations are not new to the mining industry. Unlike what many people would like to think and believe, mining has been pretty advanced in terms of adoption of new technologies and new systems. For example, analysis of image of froth in the flotation process, or image analytics applied on rocks to identify the size of the input feed material, or advanced process control to look at multiple data sources and using that advanced process control to optimize recoveries and grade of the processes. They have been existing in the industry for decades. So in terms of data, there is massive amount of data that is being generated by these advanced technological solutions that have been there for decades in mining. Most of the machines that are present in mining, they're all connected and they provide data in terms of temperatures, vibrations, pressures, different kinds of data sources are already available. So in the procurement language, we define non-performing assets like NPA that is sitting idle for long enough time that you can declare that it's a non-performing. It's only carrying cost and not contributing to the outcome or the revenue. And that is precisely the case with the mining industry. There is so much data available, but there is no one to analyze that data because it's humanly impossible. We were working with a large mining company in Chile, and they used to get about 27,000 alerts in a month per person. It is humanly impossible to go through each and every alert and find out how many alerts are false and how many alerts are really meaningful, which require some action. The mining is sitting on this massive amount of data, waiting for the value to be unlocked. When you think about data being used in future within the mining industry, there are so many examples coming from exploration, coming from blasting, coming from hauling, and every single activity that happens, the data is generated, and the potential, the future is so immense. What I would just say, if I try to focus myself on the assets, on the machines, which is where Uptake's core focus is, applying intelligence on that data coming from the machines is where the mining industry is heading. If you apply intelligence to it, machines will never fail. And as I said, we demonstrated millions of dollars of value that can be delivered to a single operation, a single site. You can imagine the potential if that technology, if that analysis is implemented across all the mining companies, across all the sites. I'm talking about billions of dollars that is just sitting idle, just waiting to be unlocked. Now, there are certain great things about fair value exchange, and the concept comes from when my provider, the service provider, it could be anybody, it could be Facebook, it could be Netflix, it could be anybody who is utilizing my data in providing me some service that I subscribe to. When it comes to, for example, with the Netflix, my personal choices are used by Netflix to better their algorithm, so that a person like me, maybe some other country, can get better recommendation of movies and TV shows because Netflix knows how do I behave and what TV series I watch. So my information is used to improve the overall system, and everybody on that network gets benefited. And this is exactly applicable to mining or any other industry. I have a pump, for example, I own a mining operation and I have a pump. I give that data to a system of intelligence. The pump has a unique signature, a unique data about the failure patterns and everything, and that data makes the whole system better. Everybody on that network, their algorithm gets better. So my data is making the system rich. At the same time, other people's data is making their system rich too, and I'm also a beneficiary. From that perspective, I don't mind giving away my data because I'm also a party to it. I'm also a beneficiary. If some system of intelligence starts selling that information to my competitor, that's when things get tricky. That's an important part. And that's where at Uptake, we are extremely mindful in terms of preserving the integrity of each and every data point that you get from the customers. Of course, it's making the system intelligent, but there should not be any violation of that data integrity.
Minerva Intelligence takes a cognitive AI approach to delivering solutions to help you get more out of your data. Here's Sam Cantor, Section Head for Economic Geology, to tell us more.
My name is Samuel Cantor. I'm originally from Colorado, and I'm the Section Head of Economic Geology at Minerva Intelligence. And my path to AI and geoscience applications of it took a turn that I think a lot of geologists find themselves, where you start in one thing and you wind up in something completely different. I started in phosphate mining exploration and then wound up studying my master's at UBC in Vancouver on isotopes and fluorescence. And that led kind of sideways into my position at Minerva Intelligence. And we're a knowledge engineering company that's focused on bringing the cognitive AI side of the spectrum to mining applications. We've got several tools for the mining industry, and these tools are actually fairly domain agnostic, and we actually have tools for natural hazards. There's a broad spectrum of geoscience issues that our technology is capable of tackling. For me, a lot of what artificial intelligence applications have to say about mining problems in general is really about the cost of prediction and the value of prediction. From that, you really look at a lot of the problems that are more high profile that have been solved: autonomous driving, optimization of processing, Each of those is dealing with a prediction problem that you have a large amount of data for, and you get very quick responses. Your self-driving truck can tell whether or not there was something in front of it immediately. In the same way that if you're trying to use a machine learning algorithm or some kind of artificial intelligence to optimize your recovery operation in the mill, you have what went into the mill, you have the recovery that finished. The more challenging applications are where you don't have a good answer key to your problem. And that occurs in a lot of different problems when it comes to ore prediction, mineral exploration, brownfields, greenfields. And at the end of the day, those predictions, oftentimes, they'll require a robust explanation that you can kick up the chain to your superiors. These problems of uncertainty and prediction can be viewed through the lens of how much does our traditional prediction cost, whether that's hiring a consultant to evaluate the problem and write us up a report to predict it, and how much does the explanation of that person matter. Some mining problems, you actually don't even really need to worry about why something works. As long as it's lowering the cost or increasing the recovery, you really don't need to ask it. And certain applications in mining that are a good example of that are mine planning optimization algorithms. So certain algorithms that take a look at where all the employees are on the mine and where they need to be, and it just optimizes everyone's shifts. And you don't actually need to know what it's doing as long as your team is running more efficiently. I think when people start to review their procedures and they start to think of, okay, what is the turnaround time on this decision traditionally? We have to seek the consultants, we hire the consultants, they collect the data, and then they give us an answer. Those kinds of problems, that kind of thinking, evaluating their prediction value chain, that's something that I think mining companies can really, really benefit from. And none of these are ever going to be a one size fits all. It's always going to involve the geologists and technical staff on the ground knowing the ins and outs of this system. And really the ideal scenario is to just view all of these tools as a way to augment the capabilities of your existing professional staff and just let them do their job better. Minerva is a knowledge engineering company. And what that means is that we focus specifically on the knowledge within a domain. It's not enough to have a large amount of data. You need to have data in context. If you ask your chief geologist about the mineral deposit, they won't list you a bunch of facts about the deposit, right? They know every component about it, which components are connected to other ones. They can understand the relevance of your question. So Minerva's approach in the cognitive AI sphere tackles a lot of the main problems that traditional operations have, and also problems that traditional operations will have trying to incorporate AI. So some of the things we do come down to data preparation and really knowledge management. And what that means is sometimes we'll take an organization's data and we'll really look at down to the words that they use, why they use them, and what they intend to use them for. A lot of times in the geosciences, because so much of the actual practice is subjective, you'll find that a lot of stakeholders in the operation are trying to take highly variable subjective data and really put it into this objective numeric modeling, when in reality, if you address the issues in terminology and standardization on the ground floor, it can really supercharge what you can do later. So what we do is we start really with looking at the words that an organization uses. And from there, we have multiple solutions that can help them maintain this new standard that they've created with us. Using that, we have other tools that help them manage their documents, their mineral exploration procedures, and the information that they collect and gain insight from with their drill campaigns. It all starts with the sort of science itself. Our approach is really helpful for organizations who understand that the start of the mining value chain has a direct impact on the end of it. In the last few years, people have seen a greater push for the concept of geometallurgy, which is where your geologists understand that the data they collect affects the process engineers in a certain way, that the mineral content of what they're collecting might affect the flotation And all of these may affect the environmental remediation at the end. Our approach of focusing on getting the words right and the actual terminology that your scientists are using, this has so many downstream effects. And I think once companies start seeing that, they'll really realize that it allows them to do their traditional operations better. And then it also allows them to employ more data-hungry versions of artificial intelligence in a much better way. Ideally for me, I'd see data being used in a much clearer way. A lot of organizations right now are in this data collection trap. The cause of it is irrelevant. A lot of companies and projects collect as much data in as many ways as they can. And then what you really find is a lot of people don't really use it. And so for me, what I'd like to see is a better focus on the why. Much like if you're designing a software program, you don't just make features just because they're cool. You want to make a feature that a customer would ideally desire or use. So in the same way that you want to collect data with a clear end goal in mind. The consequence of that is really that a lot of companies have this mountain of data that they've collected, and then they kind of expect that maybe a big data solution can solve it. The problem is if they hadn't really thought about what they wanted to use the data for at the end of the chain, they didn't really collect the data the right way. And so what some of these organizations are finding is despite the fact that they have hundreds of thousands of records, they really can't use them without a lot of effort. It'd be really interesting to see companies focus a bit more on taking charge of that and initiating a data manager or a data intention professional. And one of the things that we like to propose is the concept of a knowledge management officer. And that kind of person is essentially in charge of the domain knowledge that a particular application within the mine or the exploration program is responsible for. And a knowledge management officer may use one of our software programs like Solace or Leo to really tie in what their data is being used for. But at the end of the day, it means that when the organization's management finds out that they can't use this data they spent $50 million to collect, really, there's somebody there who should have been curating it. It's one of these problems that's difficult for companies to value because it's similar to, an IT professional where if you don't have one, it's really expensive, but when they're doing their job, you don't see all the problems that they're solving before they happen. So this concept of a knowledge management officer who can sort of handle the data and make sure it's in the right places at the right time can prevent a lot of headaches when the geology team transitions to the mining team transitions to the environmental team. So that's something that I'd like to see more in the industry is people caring about data in that way and really making it, there's this buzzword, interoperable. It's something that everyone in the mining industry knows. There's so many comics about how the geology team speaks a different language than the mining team and all this other stuff. Everybody in the mining industry knows that, but then few people actually really take steps to resolve that. And that's really what a knowledge management person can do. We are obviously fairly big proponents of making data a bit more public. I come from an academic institution that is focused specifically on industry academia bridging. The Mineral Deposit Research Unit, where I did my master's, did a really good job of getting a lot of important mining stakeholders in the same room to say, look, if you all pool your resources and you all research the same problem, you'll all benefit. And I think what we're starting to see with Unearthed is a data competition provider out of Australia. We're starting to see a little bit more of that, the Integra Gold Rush Challenge, they're doing a Gawler Craton Challenge right now. And hopefully what companies can see is that unlike a tech company or a industrial manufacturing company whose trade secrets are the manufacturing process, a mining company already owns the rights to the ground. So if somebody in the public learns some insights about your data, you own the mineral rights to that. So outsourcing that or crowdsourcing some of your data really has a much larger opportunity to help you. And I think it's a bit of a carryover from a previous culture of hyper competitiveness and secrecy. But I think what we're seeing now is with the declining discovery rates of all these locations, that a more collaborative model will really benefit a lot of companies, and really outsourcing it and letting the public handle their data a little bit more. Because if you spend $10, $50 million collecting data and you're not actively researching that data, trying to do something with it, then nobody is. All that value sits on the shelf unused. And this is in contrast to software companies or other industries where a lot more of their information and their effort is public. And so people can work on finding bugs for a software company. People can't work on finding bugs for a closed data system mining. I think a bit more of a change in the perception of sort of that risk calculus would be helpful. And it's understandable why companies don't want to have everything public. I think really at the end of the day, they'll benefit more than it'll hurt them.
Motion Metrics are focused on developing advanced monitoring solutions designed to improve safety and productivity in mining operations. Let's hear from President and CEO, Dr. Shahram Tafazoli.
Hello, my name is Shahram Tafazoli. I'm the CEO and founder of Motion Metrics. We are a technology development and commercialization company out of Vancouver, Canada. And we do have sales and support offices around the globe. Our vision is that we want to inspire a new generation of safe, sustainable, and intelligent mining. And in order to achieve that, our mission is to combine artificial intelligence with machine vision to address some of the toughest challenges in mining industry. It's quite well known within the mining industry that accessing resources, valuable ore coming out of our planet Earth is becoming more and more difficult. It's important to use sensors. It's important to use advanced analytics, processing big data, and so that we can make mining more productive and efficient, as well as autonomous operations are quite commonplace in mining now. And those are the leverage of AI in order to improve traditional mining. At Motion Metrics, we have targeted some of the challenges, as I mentioned earlier, in mining. For example, one of our most popular products is called Shovel Metrics. Is a rugged industrial camera which is installed on top of various type of mining shovels. It has exposure to the bucket of the shovel as it operates, and there is an embedded computer, and there's also a cloud computing component to that. And what the system does is that camera system, together with the AI, looks for missing teeth in the bucket, which is known in mining. Whenever a tooth breaks, it can end up in the crusher, or even if it passes through the crusher, it can go on the conveyor belts and cause a lot of damage and problems, or even get jammed in the crusher. People have been injured or even lost their lives trying to fix those jammed crushers, which are a big bottleneck in mining. That's one of our most popular products, which is installed on a few hundred shovels around the world today, and loaders as well. And on top of that, we also do novel stereo camera-based analysis of the rock sizes within the mining industry. First, I'll explain why it's important. As you can see, I have a poster of rocks in the background here. And it's known, the whole process of reducing rock sizes within mining, which is called comminution, is known to be very energy intensive. Almost half of the energy in a mine is consumed for that purpose, and 4% of the world electrical energy goes for comminution. So in order to get a handle on that on each operation, it's important to measure the rock sizes, both at the face of the mine and on top of the trucks, inside the shovel, in the crusher, on the conveyor belt. I'll just very briefly show two of our products. Here is our handheld product. Is called Portametrics. As you can see, it uses stereo cameras. When you look at the rock scene, like what I have here, you can see it's enabled. You take a picture of that scene, and it automatically does analysis of the scene and the segmentation of the rocks. And this is already a safety product and has been deployed at many sites around the world. And here, what I want to see a more advanced generation of that, what we call Smart Camera 3D. We have developed everything on this device, from the hardware to the software and embedded GPU, which does AI inside our company. It's essentially stereo camera, high res, and what our plan is, we call this an industrial Internet of Things device, or IIoT, for this device to be installed in various locations, looking at rocks, but analyzing them in a sense of 3D, doing segmentation, sensing boulders, which are big rocks, which are known to cause problems, and reduce efficiency of the mines. So this is just a quick example of what we do related to sensing the particle size distribution. At Motion Metrics, one of our initiatives in recent years is we are more moving toward the SaaS model, which we call it instead of software as a service, is really system as a service, because our products have the hardware components, as I showed earlier, as well as software component, both on the embedded system and on the cloud. And the idea is we provide APIs, we closely work with the customer on a service and subscription basis, where we make sure the customer is getting value from our product. And also we are able to exchange data in a fair way with the other suppliers to the same customer. Maybe it's a dispatch provider, maybe it's another supplier is measuring other things. We can provide them some of our data in exchange for that, and to make the whole mine run more smoothly. The response has been amazing. We have our systems over the last few years deployed in many mines around the world. We have systems on hundreds of shovels and loaders, and our newer what we call IoT, Internet of Things devices, which are belt metrics and truck metrics, which are pretty much based on smart camera 3D. We are getting really good traction. And one interesting observation I would like to share with the audience is that we have noticed pretty much a majority of the new mines that open, they become our customer very fast, and they are interested in a variety of our offerings because they understand the value that these products bring to their operations from the safety and the efficiency point of view. And we have sustainability initiatives, a big news that is coming up in the coming weeks that we will announce to show how we are also expanding our offering to make mines more sustainable. We have, because our offering includes Metrics Manager Pro, which is our cloud-based platform and AI solution, we are able to get an insight about how the products are performing, look at the log data, look at the reports. And based on that data, we know in the last few years, we have detected more than 200 successful tooth breakages. And that means probably a good number of lives have been saved, and injuries have been avoided, and also mine shutdown or crusher or conveyor belt damages have been avoided. So we really feel good about that. And the growth we have experienced in the last 4 years, a year-over-year growth in our revenue and the number of customers and the number of systems that we have deployed, it's an evidence of how the market is warming up to our novel solutions. Our biggest observation where we are patenting different technologies around that is that the scenery of rocks is one of the best scenes to look at with stereo camera and with what we call machine learning. So essentially, if you want to get an idea what's the fragmentation of the scene, a human being will go and try to delineate each rock and do some scaling to convert the image to actual distribution of the rock sizes. And really, with thousands of such images, we can train our AI-based solution. So now imagine you have this type of intelligent IoT devices installed in various locations at the mine, and instantaneously they are taking images, they are uploading on the cloud, and then now you have a very nicely measured mine. Now we can adjust the crusher setting, the blast parameters, everything that would really start enhancing the operation and result in much improved safety and efficiency in the mine. So that's the basic observation in the Motion Metrics that we are capitalizing on that. And we would like to see these solutions pretty much in every mine around the world. because mining needs to be safe and sustainable.
Thank you both, Dan Jevons and Ben Amaba, for sharing your insights and showcasing how Shell and IBM are approaching AI, and thanks to our audience for attending today's webinar. And look out for more from Shell and IBM on the big issues facing mining and how the Oren Marketplace can help its digital transformation. Our next webinar will focus on the rise of digital twins. Goodbye for now.